Hello everyone. Today we will discuss the mechanical properties of fluids. So to start the chapter we need to discuss a few important terms. The first is fluids. So what are fluids? Anything which can flow, right? For example, liquids and gases are considered under the fluids. So things which flow. For example, liquids and gases. Then thrust, you have studied about thrust in class 9th. Thrust is the normal force acting on an object. So this is the perpendicular force acting on an object. So its unit is Newton. Then we have pressure. Again, you have studied this in class 9th. So pressure is force acting per unit area. We know that this is F upon A, and SI unit is Pascal or Newton per meter square. Now Pascal's law, again you have studied this in class 9th. We need to just recall this, that if we ignore the effect of gravity, then the pressure at all the points of a fluid is same, right? So pressure at every point of a liquid at rest is same, right? And whatever excess pressure, if we apply at any point of the fluid, it is transmitted equally in all directions. So any excess pressure applied at any point on a fluid at rest is transmitted equally in all directions. Then we have experimental verification of Pascal's law. This is very interesting. So we'll draw a diagram for that. So if we have this container having 3 openings, it has 3 openings such that the area of cross section of this is half of this. Suppose area of cross section of this is this A. Its area of cross section is A by 2 and its area of cross section is 2 times of A, right? And here we have one piston, here we have the second, and here we have the third piston. A fluid is filled inside this container. right? And if some force is applied, if force 2F is applied here, then it is observed that in order to keep these pistons at their place, here we need to apply a force F to keep these pistons at the place. Here we need to apply the force F by 2, because whatever force we are applying here is resulting in a force which is acting on the piston from the inner side of the fluid. If equal force is applied from the other side, this piston will be stopped from moving. Similarly, if the force equal to this transmitted force is applied here, this piston will be stopped from moving. So it was observed, if we take this as opening O, P, Q, right? So we'll just mention this in short. If force, if 2F is applied at O, right, then F is required at Q, and F by 2 is required at P to stop the piston from moving out. So if this much force is required to stop these pistons from moving outwards, that means how much is the pressure at P, how much is the pressure at Q, and how much is the pressure at O. So for pressure at P, the force is this, area is this. For pressure at Q, force is F, area is A, and for pressure at O, the force is 2F, the the area is 2A. So it is clear that pressure at P is equal to pressure at Q is equal to pressure at O. That means whatever excess pressure was applied at point O is transmitted equally in all the directions, right? Now we'll discuss the variation of pressure with depth. So for this, we need to draw another diagram. Now for that we need to consider a beaker. Suppose we have this beaker having fluid inside it. This fluid has a density rho. The density is rho. We imagine a small cylinder imaginary cylinder with area of cross section A and the height h. This cylinder is inside the fluid. So suppose a pressure P1 is applied by the fluid at the upper end of the cylinder. and the pressure P2 is applied by the fluid at the lower end of the cylinder. Let's consider the mass of this cylinder is m, then obviously its weight will act downwards. So we are talking about equilibrium. For equilibrium, the vertical motion and the horizontal motion must not be there. So you can say that for equilibrium, net vertical force must be 0 and net horizontal force is also 0. We are talking about net vertical force. So let's check out, due to this pressure, how much force is acting at this end. We know that the formula for pressure is force upon area. So force will be pressure into area. So you can say that if this is the pressure acting here, so that means P1 into A is equal to F1 is acting at this upper lid, and on the lower lid P2 into A, that is F2, is acting here. And what is the weight? Weight is acting downwards. So for vertical equilibrium, we know that net downward force, that P1A plus mg is equal to P2A, right? So from here we can write mg is equal to P2A minus P1A. Mass can be written as volume into density. So here volume into density into G, P2A minus P1A. Now if we look at this cylinder, if this is your cylinder, I am drawing it out. So A is the area of cross section, H is the height. What will be the volume? Volume will be A into H, area of base into height. So this can be written as A H rho G. Here I can take A common, I can write P2 minus P1, right? From here A can be cancelled. So therefore P2 minus P1 is equal to H rho G. That means excess pressure at depth is proportional to height, proportional to density, and proportional to G, right? And let's take a special case. If we take this cylinder to the surface, the upper surface of the cylinder to the surface. So we are taking case 1. If the upper surface of the cylinder is at the surface of the liquid, is at the surface of liquid, what will we consider? We will consider that P1 in that case will be atmospheric pressure, because it is exposed to atmosphere now. And then we won't require any suffix for P2, so we can write P2 is equal to P. In that case, what will our expression become? If this is our first expression, so from this second expression, from 2 in 1, what will it become? P2 will be P minus PA is equal to H rho G. This difference of pressure and atmospheric pressure is called as gauge pressure, right? So what is gauge pressure? Gauge pressure is the difference of absolute pressure and atmospheric pressure, right? So if I want to find this absolute pressure, here P is considered absolute pressure at depth, right? So this, if you want to find absolute pressure, then you need to add atmospheric pressure. If you want to find gauge pressure, this will be the difference of pressure at depth minus atmospheric pressure. So I hope this concept is clear to you, right? And for horizontal, we know that for at every point which is correspondingly opposite, these will have same pressure. So these pressures will cancel out the forces due to these pressures. So why this is 0? Because opposite pressure forces are equal at every point, right? So if we talk about this, so this pressure is equal, force is equal to this pressure force. So this way these will balance out, right? So this was all about today's lecture. Thank you and have a nice day.